Every time you check the weather, order some food, or message a friend on your phone, you're using something you can't even see, something that's working like crazy in the background. We're talking about APIs, and let me tell you, they're one of the best places for hackers to find bugs. So let's pull back the curtain on the top security flaws that are probably hiding in the apps you use every single day. Okay, so what in the world is an API? The absolute easiest way to think about it is like a waiter in a restaurant. You, the customer, tell the waiter what you want from the menu. That's you using your app. The waiter takes your order back to the kitchen, that's the server, and then brings back exactly what you asked for. Simple, right? These APIs are the digital waiters that make pretty much every modern app work.
And this is where things get messy, because that digital waiter isn't just carrying a food order. No, it's handling your private messages, your location, your most personal details. If a hacker can figure out how to trick that waiter, they can get access to all sorts of things they should never, ever be able to see or do.
So the first and honestly the most common type of flaw is all about identity. It all comes down to an API failing to ask two very basic questions. First, who are you, really? And second, are you actually allowed to do that? Now, in the official security world, the number one flaw has this super technical name: broken object level authorization. I know. It sounds like something a lawyer wrote for a bunch of engineers, not for us. But what does it actually mean in plain English? Let's just cut through the jargon. Imagine your mailbox key has the number 123 stamped on it. Well, this flaw is like being able to scratch out that 3, scribble in a 4, and suddenly your key opens mailbox 124. It is literally that simple and, yeah, that terrifying. In the hacking world, this has a nickname, an IDOR, which stands for Insecure Direct Object Reference. It's what happens when an app isn't double-checking if you actually own the thing you're trying to look at. It just sees a valid ID number and boom, it hands over the data. This is seriously one of the most common bugs out there today. Okay, now let's look at a related problem that's all about permissions. In basically any app, you've got different kinds of users, right? A regular user can edit their own stuff, but an administrator, well, an admin can edit anyone's profile. They're playing with completely different levels of power. So this second bug, which we call broken function level authorization, is what happens when the API gets confused about who is making the request. It's when a regular user finds some kind of secret backdoor to use an admin-only power, like deleting someone else's account, all because the API forgot to check their ID at the door. All right, let's move on to our next big category. This one is all about APIs that just talk too much. The ones that have a serious problem with TMI, they overshare tons of sensitive details in the background, even if you never see it on your screen. So picture this. You go to your profile page in an app. On the screen, all you see is your username, Jane Doe. Seems perfectly fine and simple, right? The app just asks the waiter for your username, and that's what it showed you. But, and this is a huge but, here's the problem. In the background, the server didn't just send your username. That API, in a rush to be helpful, sent back the whole shebang: your username, your private email, your home address, and heck, even your password hint. This is called excessive data exposure, and for an attacker, it's an absolute goldmine. And attackers can take this a step further by exploiting that overeager helpfulness. Let's say you're just trying to change your username. What if you could sneak in an extra, hidden instruction into that request? Something like, is admin true? Well, mass assignment is when the API blindly accepts that extra data, and just like that, you've promoted yourself to an all-powerful administrator. So far, we've talked about flaws in the app's logic. But some of the most dangerous vulnerabilities are actually cracks in the very foundation of the system, the way it's all built and configured from the ground up. And this covers a lot of ground. It could be something as simple as a security misconfiguration, like a developer forgetting to change a default password on a server, or it could be a lack of rate limiting, which is like a nightclub having a bouncer that lets someone try 1,000 different keys on the front door every second without ever stopping them. Or you get really dangerous stuff like injection flaws, where an attacker basically smuggles a malicious command disguised as normal data, tricking the whole system into doing their dirty work for them. And then there's the digital version of forgetting to lock the back door. See, companies are always updating their APIs. They'll release version 2 to fix a big security hole in version 1. But the problem is, sometimes they forget to actually shut down the old vulnerable version. So an attacker can just go find that old V1 endpoint, which is still running and connected to all the data, and walk right in through the old known flaw. Okay, we have covered a lot, I know. So let's boil it all down.
If you really want to start thinking critically about app security, you don't need to memorize a giant list of flaws. You just need to get a handle on the big three. Think of this as your starter kit. The best way to do this is to just ask three simple questions. First, the IDOR question. Can I see something that isn't mine just by changing a number in the URL? Second, the data exposure question. Is this app's API oversharing sensitive stuff in the background? And third, the old versions question. Is it possible that an old, forgotten, insecure version of this API is still floating out there?
Honestly, if you understand just these three ideas, IDRs, excessive data exposure, and those forgotten old assets, you understand a huge piece of the puzzle. These are the heavy hitters. These are the bugs that security researchers find over and over and over again. Think about it. Every single app in your pocket is having hundreds of these tiny conversations with servers every minute of every day. They are all powered by those digital waiters, the APIs. So the real question you should be leaving with is this. Now that you know what can go wrong, how confident are you really in the security of the tech you rely on every day?